Hey everybody, how's it going? So today we're going to be working on yet another MacBook. I'm sorry that I haven't made time to do more of these board repair videos. Putting together the new store has been driving me crazy, financially, stress-wise, and general work-wise. And I haven't had the time to actually sit in my office or organize my office or do much of anything. We've been quite busy moving, and moving means that people that are moving cannot do their normal work tasks, which means that other people must do their tasks, plus the half of the other people who are moving. That's a lot of work. So sorry that I haven't been able to do the board repair stuff as often as usual. This is a board that sent some of us for a loop, even though it's a clearly simple and obvious issue, and I figured if it's something that sent us for a loop, it's probably going to drive you a little nuts as well. And I don't like only having videos that make us look smart. I've posted lots of board repair videos where it's something obvious and we were just all being idiots. And I think that anytime we're idiots and we figure it out, that we should share it so that maybe you don't make the same dumbass mistake that we made. Because let's face it, everybody makes dumbass mistakes. Most people on the internet are, they don't like to admit when they do something careless or silly. They like to pretend that they're perfect. They like to pretend that every single thing they've ever done throughout their entire life was perfectly thought through, that they've never gotten tired, they've never gotten burned out, they've never missed something right in front of them because they're just so perfect. The beauty of the anonymity of the internet. So here, I'd like to show you what was going on with this MacBook Air and what I think some of you may miss if you misread the schematic the same way that all of us here misread the schematic. This board went through multiple people, and all of us, perhaps because we're tired, perhaps because someday we get here at 7 and don't leave until 9 or 10 because of moving. We just did some stupid shit. So this was a no backlight MacBook Air, and I'd like to show you some of the preliminary work that was done here. You can see that there's quite a bit of work in the backlight enable area. This is going to be a transistor that sends the backlight power to the entire circuit. So here you have the backlight fuse, which never blows because it's a MacBook. Then you have the transistor that it goes to. And this transistor is going to open or close and send backlight power throughout the rest of the backlight circuit. But this transistor has to open for that to happen. And this transistor is going to govern whether this transistor opens. So we are going to open up the schematic over here. So this is 8 volts from the battery. It's going to go through the fuse, and this transistor is going to open or close to allow power to pass through the circuit. You don't want backlight power going through the circuit at all times, because maybe you've got the lid closed, maybe you've got your energy saver preferences set up so that the screen turns off after 2 minutes. No need to have power going through if it's not supposed to. Now the question is, if the CPU works on 3-volt logic, yet this transistor is going to open or close based on higher voltage logic, how does that work? So this transistor that you see is a P-channel. One of the things that I went over in my How Does a Transistor Work video is that a transistor is going to open based on the voltage at its gate. So see over here you have these transistors. These make it a little bit more obvious because they have gate, source, drain. It's all written. So power is going to go, source to drain, drain to source, depending on what's at the gate. Think of it like a light switch. This is going to be 120 volts. That's going to be the wire to your light bulb. And this would be the physical switch at the gate, except instead of a physical switch, it's an electrical one. Now, this is a P-type MOSFET. Why does that matter? There are 2 types of transistors that I give a crap about when fixing an iPhone or a MacBook, P-channel or N-channel. A P-channel MOSFET, the way this works is the gate voltage is going to determine whether it opens. Now with a P-channel MOSFET, when the voltage in the gate is lower than the source, it turns on. And on an N-channel MOSFET like these ones, when the power on the voltage in the gate is higher than the source, it turns on. If you're not sure if this is an N or a P-channel MOSFET, you can just Google the number of the transistor, and sometimes the schematic may be nice and even tell you right next to it. If the Apple engineer was feeling happy that day, maybe he got late or something, he'll write P-type so that you don't have to Google. And that's what seemed to have happened here. So everybody say thank you to the Apple engineer that wrote the type of MOSFET right here so that we don't have to Google. You can also tell by looking at the picture, but if you're really new to this, you're probably going to forget what the picture is. You have here is a resistor, and this resistor is going to take the 8 volts from the fuse, and it's going to immediately move it to the gate. Now, the resistor is not going to have a real voltage drop across it, so you're going to have 8 volts in the source and 8 volts in the gate, which means this thing never opens and never turns on, right? But wait, there's more. You have another resistor on the bottom that's going between the gate and grounds. This will act as a voltage divider. I went over this in my What is a Voltage Divider and How Does That Work video. A voltage divider is going to take the voltage that's at the top and lower it. You put one resistor between the high voltage and where you want the voltage to be lowered, and another resistor between where you want the voltage to be lower and ground. and that is going to lower your voltage. But in order for this voltage divider to work, this has got to hit ground, right? Or else it's not going to have any place to send it. This needs to go to ground. And what's blocking it from getting to ground but these two transistors? So these two transistors are going to open when you have EDP backlight enable and backlight platform reset L present. And then this voltage will get sent to ground, which means that this will be a happy little voltage divider, which will divide the voltage. And then instead of having 8 volts over here, you'll have something like 2 or 4 volts. And then this transistor will open. And this area looked very messed up, so it looks like all of that was reworked. You can see the two resistors over here for that voltage divider are nicely soldered on. You have your happy little jumper wire over here. All is good, all is well. These probe points and these these pads have all been fixed up to look nicer. So let's see where it is this board left off before it got its way here. Let's see so I'm going to turn on Paul Daniels' lovely and amazing multimeter software so that you can see and follow along on the screen what it is that we're doing. Now, if I take a look at the backlight fuse, you'll see that we have 8 volts there. Let me just change the range on the meter. You'll see we have the 8 volts that I expect from the battery. On the other side of the backlight fuse, we've also got 8 volts. Now, if we go to the beginning of this transistor over here, Q7706, the input is going to be on pin 4. We measure that. Eight volts. Now on pin 1, that's going to be where it's outputting, right? Uh-oh. Let's try that again. Eight volts. I just blew up the fuse. LOL. Okay. I just nixed something with my multimeter probes, so let me just replace that backlight fuse that I just blew up live on camera. I'm not sure if you guys were able to catch that, but I just took that fuse and went poof with it. That's the beauty of editing, is that nobody has to see just how stupid I am. There's only so much stupidity I'm going to put in one video. I'll let you guys see some stupidity, but you know it takes work because I just blew a fuse in an Apple product. You know how adorable those damn fuses are. Those do not come off easily. Alright, I'm going to take that fuse and I'm going to put another one on, but I'm going to put this fuse on backwards in protest. I'm using hot tweezers instead of hot air, which is making life hard for no good reason. For the people that ask why I don't use hot tweezers, like, watch. So see, this is the backlight fuse, right? And I'm just going to sit there with my tweezers. 5, 4, 3, 2, 1. It's just so annoying. Come on. There we go. Oh my god. I could probably make my own fuse in the time it takes to desolder something with tweezers. You're not a P, now you're a D. I'm putting too much effort in to try to make this perfectly straight. Good enough. For rock and roll, I'd say. I blew an Apple fuse. Okay, we got 8 volts. 8 volts on the other side of the fuse. 8 volts on the input of the transistor. 8 volts in the output of the transistor. 0 volts on the coil. And if you take a look at the schematic and the board view, you'll see that this is supposed to go from the transistor to the coil. PPVin SOSW LCD Bicklet FET. PPVin SOSW LCD Bicklet. This goes to here. Now, it's not connected on the screen. It says there is a sense resistor between PPBus SW LCD Bicklet per and PPBus SW Bicklet on the sensor page. And if we follow along on the board view over here, we click, you'll see that this doesn't go directly to the coil. This doesn't go directly to L7701. It goes to this, R5490. R5490. So let's take a look at R5490. Now, when you look on the schematic, this is a resistor that's not actually there. So most people are going to say at this point, well, this resistor's not actually there. So why would I check it? R5490 says omit. See where it says omit? No resistor there. And as you see when you look on the board, there is no resistor placed for R5490. But what you can see is that the transistor clearly makes a pathway from to the coil through this. So here's the transistor's output right over here. I'm just going to up the lighting on the camera over here so that you can see, up the exposure to some. Let's up that to an influencer level of exposure there. And you could see that the transistor's output goes to here. And then they don't have a current sense resistor here. This is actually just, this essentially might as well just be bare wire inside the PC board, where here goes to here, and that's going to go over to the coil. So the coil is going to receive its power not from R5490, but from this trace on the board where they decided we're just not going to put a resistor there. Screw having a current sense circuit. We'll leave that for the Retinas. And there's supposed to be a trace there, but there's not because you have this thing over here. And what some people may think is I'm not going to check that resistor because the board schematic says it's not there. So why bother? Why would I check the schematic to see what the resistance is of a not present resistor? Well, just take a look at the board. Yeah, there's no resistor there. They omitted it, but they replaced it with a wire, and that's clearly burned off in the first trace here. Now, what a current sensing circuit would do is a current sensing circuit would say, oh, it looks like you're using too much power. Please stop before you die. This is a very useful type of circuit to have. It's also why on the MacBook Pro Retinas, you don't see backlight fuses blowing from 2013 and after, whereas they do blow on the A1466, A1465, and A1369, and so on and so forth. It's because they don't have a current sensing circuit. The current sensing circuit would cost Apple probably an additional 19 cents to put in there. And you only bought the $999 computer. You didn't buy the $1,200 computer. So what the hell do you think you're getting? Do you think they're actually going to put that extra 19 cents in and make sure that the fuse doesn't blow so that if you remove the short, it'll just work again nice and easily without soldering? When you only bought the $999 model, get the F out of here. So they actually put all of this in place. And I will say, I will compliment Apple on the fact that the A1502s and the A1398 from 2013 and onwards do have a current sensing circuit there. The way that works is you have a current sensing resistor, and if it notices, and you'll have a backlight chip reading voltage on each side of the resistor. And if there's too much of a voltage drop, it'll assume too much power is being drawn and immediately close this transistor rather than just letting it go. Because right now, this transistor is going to be open. Like if there's a short to ground, it don't care. That transistor is open and it's just blowing through everything. But on the Retina models, that is not the case. They have a current sensing circuit. I can show you that by opening up another schematic here for perhaps a different machine. Let's see if we have more modern, something. Here we go, something like this. We'll open up the backlight circuit for this model. And see, this is going to be your current sensing circuit. So you have the fuse, and you have the transistor before it goes to the backlight circuit, but before that you have this resistor. And this is a current sense resistor. This is a shunt resistor. So you have a resistor, and then on each side of the resistor, you have a line going to the LED driver. It's going to sense the voltage here and the voltage there. And if there is a large voltage drop, then it's going to assume that it's using too much power and turn off. The way that the backlight driver chip is going to know exactly how much amperage the backlight circuit is using is by checking the difference in voltage between the input of the current sense resistor and the output. And then it's going to turn this transistor off. So if there's a short to ground and it sees, wow, why is the backlight circuit using 3 or 5 or 6 amps? This transistor turns off, and now the short circuit on the backlight side does not have a way to get to ground. And that's what saves you from having boards that look like this. Because before it can get to this point, it will get turned off. It's not going to get to this point unless it's been, passing a ridiculous amount of current for quite a while, courtesy of Apple's bulletproof, good old-fashioned backlight fuse. So how are we going to fix this? Well, that's a great question. So what we do is I'm simply going to put a little jumper wire between the transistor and here, and then it's going to work just fine. And then I can smack myself upside the head for not noticing this sooner. I don't know, just for fun. All right, so let's solder this in place. Get a nice little wire over there. I'm not going to use something that's too crazy. Maybe I'll see a sheet. Here, so backlight circuit is carrying a little bit more than normal, so I'm not going to use like a 44 or 46 gauge wire. I'm going to use a 36 gauge wire, because this does need to carry something where, you know, the screen is going to be one of the things that takes more power in the machine. And it's not carrying it for a long distance. It's carrying it for a very short distance, but it should still be capable of carrying a decent amount of power. So we're just going to do that. I'm going to remove the enamel on this enamel wire so that that it doesn't, there we go, so that it can actually conduct. Now remember, those two top pins are the same thing, so it doesn't matter if they're shorted. I'm going to use a set of tweezers that are not broken, difficult to find. Looks like somebody in my chat said that they would use speaker wire for this. You are absolutely mad. You're out of your damn mind. You're out of control, my friend. Really want just to make you happy, just to make that person happy. You know what I'll do? I'll double up on it. There we see. So I'll solder 2. There you go. Hopefully that makes you happy. Now you got a nice doubled up wire. So you have even more powers, more wires for more powers, more gauges for more backlights. Yeah, look at that. That's nice and strong. Also, I can tell that this solder joint on the capacitor up there was soldered with not the right amount of flux. So we're just going to add flux and watch what happens to that nasty. See how that looks like a Hershey's Kiss right over here? This looks like a Hershey's Kiss. That's no good. You want to have the right amount of flux so that when you solder it, it looks like that. There's not this excess shit sticking out. That's what happens when you don't use the right amount of flux. And this is why more flux is better than less for me. Because more, you know, it's going to get ultrasonic off the board anyway. I don't care. Okay. Everything there looks nice. Now I'm going to see what I get on backlight output. Do I still get 0 volts going through the circuit, or does it work properly? That's a great question. So should have used 0 AWG wire. See, that's going a little overboard. That may just be a little bit too much. Just a little bit. Okay, so we're going to put the multimeter back on the screen so that you can all see what is showing up. Let's see. So now the input of the coil is getting 8. That's beautiful. Now let's see what the backlight is getting. 8. Okay, that's no good. Backlight's not supposed to be 8 volts. So now let's check the other side of the board and check the rest of the backlight circuit. So at least we have 8 volts going through the circuit now. That transistor that was not opening before is opening. So we're going to check through the rest of this board and see what's going on there. I see flux. I see an LED driver section that looks like it's had corrosion. So we're just going to remove that. No biggie. What do you think about the newer ThinkPads, especially the Fold? It looks to me to be pretty much unrepairable. Do you agree? I haven't seen it, honestly. Like, it's not like any of these companies send me free shit, so I have no reason to buy new stuff. I pretty much use what I own until it's destroyed. Like, even my Sony camera, I haven't had the time to replace the HDMI port on it. But I got a new HDMI port, and I plan to open it at some point and get it fixed because I don't feel like buying another camera because I'm a cheapskate. And this one does the job just fine. Same thing with my ThinkPad. You know, my ThinkPad does its job. I'm not really buying a new one anytime soon. There's just no reason for me. You know, it would be nice to have something slightly newer, but I don't really have a. Like, I'm not really paying for a new one anytime soon. So I haven't really seen them. And like, I'm not a real influencer. I'm an influencer in the sense that I get spam from NordVPN, even after making 2 videos about why I don't shill NordVPN, saying that they'll pay me a modicum of money for shilling NordVPN, or I get people sending me emails about shilling shitty Android games, but I don't actually get like cool stuff, you know? If you think I'm the dude that gets the newest ThinkPads and the newest, you know, HPs or LG phones or whatever, as soon as they come out, you're thinking of the wrong YouTuber. It's pretty much just NordVPN emails here for me. There's not really much of a reason for me to consider the new ThinkPads, honestly. When I looked it up, my ThinkPad has a 10,000 something CPU benchmark score, right? So I got about a 10,000 CPU benchmark score. Now, if I were to go and buy the most expensive P73 I could, like really maxed it out as hard as I could, I don't think I'd get more than 17 or 18,000 on CPU benchmark. But that's if I'm paying for like the top of the line, best of the best ThinkPad. And that's not really good enough. I'm not even doubling my performance. But I'm going to take my ThinkPad that was about $1,200. I got mine as a refurb piece of shit, with a Xeon 1515, and I'm gonna spend, you know, $4,000 or $5,000 on another machine just to get a marginal improvement? No, that's not happening. There's really no reason for me to get a new one. That backlight enable resistor looked like it could have been soldered better. Now, if it gets to the point where I can get 25,000 or 30,000 CPU benchmark score, then we can talk. Then we can have a conversation about whether or not it's worth it for me to upgrade my computer. But like going from a 9,000 to an 18,000 for 3 times the money, it's like, what the hell's the point? Maybe if I had money to burn, but nope. I wonder what their criteria is. Lenovo sent a bunch of really fancy laptops to many people in the open source world. You probably should not badmouth them when they ruin their interface by getting rid of the track point middle button. And when they release a retro ThinkPad that sucks and doesn't have any of the features that anybody asked for in the survey, don't say out loud that it sucked. That's probably the criteria. If I had to guess, I'm most likely those 2 things. Okay, we have one resistor here that looks like it's missing as well that I should put back on. Backlight iSet, that's a 21.5K. Like, there was this company that sent me a microscope, a Dynolite. It was such a piece of crap. It was like $700 or $800. I mean, it was unimaginable what a piece of shit this thing was. It was almost like they took a 25-year-old cheap CCTV camera and shoved it on top of a microscope stand and thought that I was going to say something nice about it. It was hysterical. And the thing is, I'd love to give a good review of a product. I think I gave a very fine review to the ThinkPad P50. And I think I covered it from the perspective that most other people don't. You know, everybody else is covering it from the, like, what CPU benchmark score does it get, which is something that's already kind of answered by most stuff online. I was covering it from the perspective of usability. And I gave it a good review because I thought it was actually a really good computer. You know, I actually purchased it and I owned it. I spilled about a quart of water onto my own ThinkPad while it was on. That's how much I believed in the product. You know, that wasn't a gimmick or BS. That was me actually doing that. But I also have given a lot of other reviews where I say what I think of the product. And I think that really does screw you over with regards to that whole influencer thing. Like, once you start saying what you think of the product on a regular basis, not just once or twice, that really screws you. Because I mean, there are people that have to do that every now and then to at least give you the illusion that they're impartial. Or like, you know, they pretend, you know, and 1 out of every 10 reviews that the product is a total piece of shit, or they come up with these superficial ways of saying that they're not fully happy with the product. But you can only do that every now and then. You can't do it for like every review you've ever done. Good evening, sending positive vibes to everyone watching. Thank you very much. I appreciate that. So let's see if we have output here. Give me a backlight. Give me your backlight. Okay, backlight output is what? Oh, 22. That is backlight for an air. Yep, 22. And if I put this up, I'm not sure if you'll even see the light because I have all these other lights on here. These camera lights. So can you see that? You have to trust me that that's a working backlight because I don't have a way to turn off the camera light from here, and I don't have my overhead camera anymore either. So that is a working backlight. We got 22 volts of backlight output. So hopefully this helps you avoid the mistake that we made here from being very tired and very overworked. It's gonna. I figure that if we made the mistake, it's possible someone else could make it. Just because the component in the schematic says omit or no stuff doesn't mean you don't test it. Just because the component is not there doesn't mean it can't still troll you. The component was not there, but the trace was there. So instead of having a resistor, they just decided to jumper the trace inside of the board, and that jumper trace inside of the board was completely burned out because Apple. I can blow the backlight fuse when testing, but the backlight fuse won't blow when the board is physically burning through layers. It's an Apple product. That's it for today, and as always, I hope you learned something. Again, my apologies that I haven't been able to do these videos more regularly, but I do need to focus more on getting customers in and out the door and on the financial stability of my new place, more so than the YouTube stuff, just for a short period of time. But once that's done, I will get back to doing board repair videos on a more regular basis. In this lovely new office, we got a bunch of acoustic panels showing up on Tuesday. We got more racks and stuff showing up. There's more stuff showing up from the new store today and tomorrow. And we are going to be putting the stuff together, and I hope for it to be a lovely new place. It is much less claustrophobic, and once the place is actually done, I'm sure it'll be great. We do have hearings in, I believe, Colorado and Maryland showing up on, I believe, March 5th and March 11th. So do look that up on Legiscan, or you can join the Discord. There should be a link down below to join the Discord so you can keep track of when these right to repair hearings are occurring. I'm going to do my absolute best to just like plow through all the tickets here, setting everything up and getting the place up and running financially fit so that I'm able to make these hearings and testify at them. I can't promise it, but like 99% I'll be able to do it, and I hope to see some of you there if I'm able to make it. So that's it for today, and I'll see you all in the next video.